Hey everyone, this is Andrew and I have another information for you. Multi-value intervals are multivalues that have a range of outputs. For multivalues, they're a lot more general and they include variables because variables are not numbers. Instead, they're just values that are not really definite. But we'll get into these kinds of multi-numbers later. However, we already know about multi-numbers because these are numbers and it could be 1 or 2. But for multi-value intervals, like this, 1, 2, 2, what do we know? If we were able to compare by the number of outputs, we have 2 in this multi-value, and then we have infinity in this value, if this is in real numbers. Because real numbers, there can be a multitude of real numbers. Square root of 2, and then 1.01, 1.25. Yes, you have a lot. Because there's a huge number of decimal places, and it keeps going on forever. New numbers by the minute, or by the second, whatever. But for rational numbers, we have aleph null, which you might have to understand it's the kind of smallest infinity because we're dealing with the number of whole numbers, and then they can be mapped on with other numbers like rational numbers. So that's something else. But for 2, this is only for integers, and this kind of interval would be obsolete. When we're dealing with arithmetic, like 1 plus 1 to 2, we can use these boundary numbers, kind of like the outputs that we do know, that they're definitely between, or they're definitely having, like the sandwich, kind of, what do you call them? Slices? Well, it's at the top and bottom, kind of closing thing, container. We get 2 to 3. And we can prove this when we have 1.5, which is between 1 and 2, then add 1, and then you get 2.5, which is between 2 and 3. For this kind of multi-value, we have 1 to infinity, meaning that there's an output n which is greater than 1, or greater and equal to 1, because this is not open, it does include 1. So what we do get is 2 to infinity. The list can go on, and for real numbers, you can get all real numbers by doing this for interval notation, which is the same as negative infinity to infinity. So this is the only time where open brackets are applicable, but when we're dealing with interval notation, which is not a multi-value, like 2, 3, it's the same as 2, 2, 3 for a multi-value. However, operations like union, they can be a bit tricky because union might not include a certain value by an open little bracket. So it's best to use intervals in that scenario. So for multi-values and with their intervals, what about variables? So for that, in that case, we can do a hole in a one-dimensional space. So for a one-dimensional space, we have a line. We have x sub alpha for this point, and then x sub omega. For this undefined region, how do we know that? So this hole must be in x. Using a multi-interval, you can get alpha to omega. And that accounts for everything between alpha and omega. And not to mention that alpha and omega are undefined. So that's about it for today. So continue learning about multi-values and see what you think. Or tell me what you think. See you later.